Have you ever looked up at the night sky on a clear, dark night far from the city lights and felt a sense of profound wonder? A sense of connection to something far bigger than yourself? It's a feeling that has captivated humanity for millennia, inspiring myths, legends, and scientific inquiry. That feeling you're part of something ancient and mysterious? That you are, in a very real sense, made of stardust? It's not just poetic, it's a scientific truth. The atoms that make up our bodies were forged in the hearts of dying stars billions of years ago. And now, the James Webb Space Telescope, our most powerful eye on the cosmos, a technological marvel designed to unravel the deepest secrets of the universe, has peered back to the dawn of time, to the very edge of what we can observe. And in doing so, it has found something that simply shouldn't be there. Something that is challenging our fundamental understanding of how the universe evolved. Imagine an archaeologist carefully excavating ancient ruins, painstakingly brushing away layers of dust and time, only to find a modern smartphone, fully functional, buried deep within the layers of history. That's the level of shock, disbelief, and excitement that scientists are currently feeling as they grapple with the implications of Webb's discoveries. It's a paradigm shift in the making. This isn't just a minor detail, a slight anomaly that can be easily explained away. It's an artifact, a cosmic puzzle piece that simply doesn't fit the established narrative. It challenges the story of how everything, from the first stars, the very building blocks of galaxies, to the formation of galaxies, planets, and ultimately, us, came to be. It forces us to reconsider the fundamental laws that govern the cosmos. The universe, it seems, is far stranger, far more complex, and far more full of surprises than we ever imagined. It's a reminder that our understanding is always evolving, always subject to revision in the face of new evidence. The neat, linear story of cosmic evolution, the one we've been telling for decades, has just had a major plot twist. A dramatic turn of events that throws everything into question. Scientists are scrambling to make sense of this beautiful, impossible puzzle, poring over the data, running simulations, and proposing new theories to explain what Webb has uncovered. What Webb has shown us isn't just a new galaxy, a distant pinprick of light in the vast cosmic ocean. It's a fundamental challenge to our understanding of the universe, a cosmic riddle that demands a new perspective, a new way of thinking about the cosmos. The story of the universe just got a whole lot more interesting, a whole lot more mysterious, and a whole lot more exciting. It's a story that is still being written, and we are all, in a sense, a part of it. To truly grasp the magnitude of this groundbreaking discovery, a discovery that's reshaping our understanding of the cosmos, we need to deeply appreciate the revolutionary machine that made it all possible, the James Webb Space Telescope. It's not just an instrument. It's a portal to the universe's infancy. Webb is, in essence, a time machine, meticulously engineered and strategically positioned 1,000,000 miles from Earth, far beyond the reach of our planet's atmospheric interference. It's designed for capturing the faintest, most ancient light that has embarked on an epic journey of over 13 billion years to reach us. This light carries secrets of the early universe. Unlike its predecessor, Hubble, which primarily sees the universe in visible light, limiting its view, Webb is a highly sensitive infrared detective, expertly revealing the celestial wonders that are otherwise hidden from our eyes, obscured by cosmic dust and distance. This unique capability allows it to peer directly through dense cosmic dust clouds, offering an unprecedented glimpse back to the universe's very first light, capturing the faint glow of primordial galaxies as they began to take shape. Hubble gave us a breathtaking front-row seat to the grand cosmic theater, showcasing the beauty and complexity of the universe as it exists today. But Webb goes even further, granting us a backstage pass to witness the very beginning of the show, allowing us to see how the universe was formed. It's meticulously designed and engineered to answer some of the biggest, most fundamental questions that humanity has ever asked. How exactly did the very first galaxies form in the immediate aftermath of the Big Bang? What were their characteristics? And where did the universe's first stars come from? What were the conditions that led to their birth? And what role did they play in shaping the cosmos we see today? So, when Webb finally turned its revolutionary golden eye towards the deepest reaches of the sky, the scientific community was filled with an unparalleled sense of anticipation and excitement. Based on existing models and theories, scientists fully expected to find relatively small, somewhat chaotic, and decidedly primordial galaxies, the fundamental building blocks from which the larger, more complex structures of the cosmos would eventually emerge. But as it so often does, the universe had a profound and paradigm-shifting surprise in store for us, challenging our assumptions and forcing us to rethink our understanding of cosmic evolution. When discoveries threaten to upend our understanding, we turn to brilliant minds like Dr. Michio Kaku. Kaku, a renowned physicist and co-founder of string theory, has a gift for making the cosmos' mysteries accessible. He spent his career exploring the frontiers of physics, asking the biggest questions. What happened before the Big Bang? Are there other dimensions? For Kaku, the James Webb Space Telescope is a catalyst for the next revolution in physics. He knows that a single anomaly can be more important than 1,000 confirmations. Moments like these, he says, are where the real adventure of science begins. When news of Webb's strange discovery broke, people wanted to hear Kaku's take. He sees not just a problem for current theories, but an opportunity for a new way of thinking. His voice reminds us, these moments are invitations to deeper understanding. So what did the James Webb Space Telescope actually find out there in the vast expanse of the cosmos? What secrets did it unlock, peering back into the earliest epochs of the universe? It found a galaxy, a colossal structure that we're calling the primordial giant, a name that hints at its unexpected nature. This galaxy is far too big, too bright, and remarkably well-formed for its age. It defies our current understanding of how galaxies should evolve in the early universe. Its very existence poses a significant challenge to established cosmological models. Scientists, armed with their theories and simulations, fully expected to see cosmic infants, fledgling galaxies just beginning to coalesce from the primordial soup of the early universe. They anticipated observing the chaotic, messy process of early galaxy formation, but instead they found a fully grown adult, a mature and massive galaxy, thriving in what should have been the universe's nursery. It was like stumbling upon a fully furnished mansion in a newly built housing development. The primordial giant is as massive as our own Milky Way galaxy, a sprawling spiral containing billions of stars and complex structures. Yet, incredibly, it existed when the universe was just a few 100 million years old, a mere blink of an eye in cosmic terms. This is a period when galaxies were thought to be in their infancy, not fully developed behemoths. Our models, painstakingly crafted over decades of research, say that galaxies form slowly and gradually, from small clouds of gas and dust, merging and accreting over vast eons of time. This primordial giant galaxy throws a significant wrench into that carefully constructed timeline, forcing us to reevaluate our understanding of galaxy formation. It's not just its sheer size that's baffling scientists. It's also the fact that it's remarkably organized, surprisingly mature, and contains a population of older stars, all of which formed far too soon, according to our current theories. It's like finding detailed blueprints for a modern skyscraper, complete with intricate engineering specifications, inside a prehistoric cave, alongside cave paintings and primitive tools. At first, understandably, scientists thought there must be some kind of mistake, some error in the data or the analysis. But after repeated and careful checks, meticulous analysis, and cross-validation with other data, the conclusion became undeniably clear. This primordial giant is real. This ancient object stares back at us from the very dawn of time, challenging everything we thought we knew about the universe's early history and the formation of the galaxies within it. It's a cosmic puzzle that demands a new explanation. Why is this galaxy such a problem? Because it challenges the very heart of our cosmic blueprint, the Standard Model of Cosmology, or Lambda CDM. This model explains how the universe evolved, with cold dark matter slowly clumping to form small structures that merge into bigger ones. The primordial giant doesn't fit. It's too big, too early. For it to exist, either galaxies formed much faster than we thought, or our understanding of dark matter and cosmic evolution is incomplete. Some even suggest the laws of gravity might have been different in the early universe. This single discovery has opened a Pandora's box of questions. If the standard model can't explain it, what can? The foundations of modern cosmology are now up for debate. Michio Kaku sees this cosmic puzzle as science's greatest triumph, not a failure. He says discoveries like the primordial giant are why we build telescopes like Webb. Our imagination hasn't caught up with the reality of the cosmos. We're on the verge of a paradigm shift. Kaku points out that physics advances through anomalies Mercury's orbit led to Einstein's revolution. The primordial giant could be our Mercury moment for cosmology. Maybe dark matter isn't what we thought, or perhaps influences from before the Big Bang shaped our universe. String theory even allows for a multiverse where conditions could have seeded rapid galaxy formation. Kaku urges us to embrace the unknown. This object doesn't break physics. It shows our knowledge is incomplete. It's a cosmic wake-up call, pushing us toward a new, more complete theory. The universe is inviting us to think bigger. The primordial giant hasn't given us answers, just exhilarating new questions. First, astronomers must confirm and study it in detail. Is it unique or the first of many? Webb will hunt for more such galaxies, and its spectrographs will dissect their light to reveal their secrets. What kinds of stars are inside? How old are they? What elements are present? Meanwhile, theorists are tweaking models, exploring new ideas, and even reviving old theories. This discovery has energized cosmology, sparking a race to explain the unexplained. The process is slow and meticulous, but it's how science moves forward. Thanks to Webb, we know where to look and what questions to ask. Ultimately, this discovery reminds us the universe isn't obligated to make sense to us. Science is a conversation with the cosmos, full of surprises and new questions. The primordial giant is the universe's latest, most stunning surprise. The most exciting phrase in science isn't Eureka, but that's funny. Every generation thinks it has the universe figured out. Every generation is proven wrong. We're lucky to witness a moment of profound revision. The journey to understand this object is just beginning, and it belongs to all of us. You don't need a PhD to feel the wonder, just curiosity. Stay curious, keep asking questions, and join us as we unravel this beautiful mystery together. The universe has whispered a new secret, and we're finally here to listen.